In everyday conversation, the word normal is simple. It describes things that are usual, expected, or typical for your daily routine. But when you open a math textbook, that common definition often disappears. You might find yourself reading a sentence where the word normal is used in a way that doesn't seem to mean usual at all. Normal is a word that shifts its meaning depending on which branch of math you are studying. It acts differently in a statistics chapter than it does in a geometry lesson. When this happens, you can find the specific meaning by looking past the text. The surrounding context and the diagrams on the page usually show you exactly how the word is being used. We can see how this works by following the word normal through 3 different classrooms to see what it looks like in practice. First, imagine we are in a statistics classroom. We've collected data on something common, like the heights of every student in a large school. Graphing all these heights forms a smooth, bell-shaped curve. In this setting, normal refers to this distribution pattern. The highest point is the mean, where most heights cluster. Toward the edges, the curve tapers off, showing that extreme heights are much less common. In statistics, normal isn't a judgment on the data, it is a technical description of this specific, mound-shaped model. Now let's move to a geometry classroom. Here, we aren't looking at groups of data, we're looking at surfaces and how lines interact with them. In this chapter, you'll see the term normal line. It has no connection to the bell curves we just saw. A normal line is a reference line pointing straight out from a surface, meeting it at a perfect 90-degree angle. When a laser bounces off a mirror, scientists measure the light's angle relative to this upright normal line. This meaning comes from the Latin word norma, referring to a carpenter's square, a tool used to ensure walls were perfectly upright. So in geometry, normal is a direct instruction to look for a perpendicular direction. Finally, we reach an advanced algebra classroom. This is where mathematicians study groups, which are sets of different ways to manipulate a shape. You might hear the term normal subgroup. While the math behind it is complex, the core idea is about a structure that remains consistent. Think of a square. There are many ways to move it, like flipping or rotating it. All these actions form a group. If we isolate just the rotations, they form a normal subgroup, maintaining a balanced identity even when other symmetries are applied. In this context, normal describes a subgroup that is structurally stable within a larger system. These 3 definitions, a data curve, a perpendicular line, and a stable set of rotations, seem completely unrelated. However, they are all linked by a similar purpose. This diagram shows these meanings side by side. Whether it's the central peak of a curve, the upright direction of a line, or the stable rotations of a shape, normal always describes a state that is balanced, symmetric, or acts as a standard reference point. Next time you see a familiar word used in a confusing way in a math problem, look at the chapter title or the diagram. Asking which setting you are in will tell you which version of the word you are looking at. Math vocabulary uses these specific meanings to describe how patterns, directions, and structures behave consistently across different types of problems.